So the next part of rate of change is connected rate of change. So this is the important one that you need to know how to do because they will ask this in exam. So you already know what is the meaning of rate of change. So now I'm going to discuss with you guys about the meaning of connected rate of change. So let us consider again the circle that we have discussed before. Alright, so we know that circle it can increase or decrease over time as time goes on. But now we introduce a new variable a, which is the area. So now we have radius and area. Okay, so we know that area of the circle and its radius is connected by the equation area equals to pi r squared. So this is a function where a varies when r varies. As radius decreases, your area of circle will decreases. As radius increases, the area will increases. So they are connected. So a is a function in terms of r. So if we differentiate a with respect to r, not t, if we differentiate a with respect to r, we have dA over dr. So this is not the rate of change of a with time. This is the rate of change of a over radius, which means as a increases, radius increases. As radius decreases, area decreases. Alright? So make sure you understand the difference with dA over dt and dA over dr. So here I write that dA over dr is the rate of change of area when its radius varies. Okay? Alright. So where does the time variable go? What does time place in this relationship? So time relates the two variables of area and radius in the form of chain rule. Okay? So if we have dA over dt, now this is the rate of change of area with respect to time. So this one, we can break this down into this equation. dA over dr, rate of change of area with respect to radius. As area grows, radius grows. As radius decreases, area decreases. Multiply by rate of change of radius with respect to time. As time goes, radius gets bigger. Alright? So this is chain rule. So this is our connected rate of change. Alright? So this is very important to understand so you can do the maths part of this section. Alright, so this relationship between area, radius and time is what we call connected rate of change. So here I'm going to discuss the step to success in solving questions on connected rate of change. Okay, just try your best to read and understand these steps. Alright, we'll do examples afterwards. So number one, you're going to have two variables to deal with only. Okay, for example, the previous example is area with radius. Another example, it can be volume with height or surface area with length. It's always going to be two variables. Okay, so the second one, you need to have the equation which relates these two variables. Previous example is area of circle equals to pi r squares, which connect area and its radius. If the relationship is complicated, they will give you the equation. If it's obvious, you have to figure it out yourselves, like area of circle, volume of cones, volume of sphere, surface area of a cuboid, etc. So for example, the volume of sphere and its radius are connected by equation v equals to 4 over 3 pi r cubed. So you are expected to know this formula. So most of the time they will not give you this formula. So this formula is what relates volume with its radius. Okay, so we have two variables here, volume and radius, which is for part 1. Now if you go to part 3, it is best if you identify what is the primary variable and the secondary variable. Alright, so primary variable is the subject here, v. Okay, it's always in front. Where the secondary variable, it's the variable which makes up the function, which is r here, not pi. Pi is a constant, pi is just a number, 3.14. Right? So if you can tell which one is primary, which is secondary. So it will be very easy for us to do the next step, which is constructing the connected rate of change. Okay, so if you have function of y in terms of x, to construct the connected rate of change is something like this. They always have this form. So the first one here is always the rate of change of primary variable. So our primary variable is y. So rate, if they say rate only, it's always over time. So dy over dt equals to, here is always the rate of change of primary variable with respect to secondary variable, which is dy over dx, multiplied by the last one is always rate of secondary variable. Okay, so let's try for this equation of volume here. So we know that the primary variable is volume and the secondary variable is its radius. So if you want to construct the connected rate of change between volume and radius, okay, so the first part here is always the rate of the primary variable. Remember, rate is always with respect to time. So dv over dt here equals to, this part here is always the rate of primary variable with respect to secondary variable. So dv over dr. And then multiplied by the last part, which is always the rate of secondary variable. Okay, so you just memorize this position. Okay, primary variable, this one is primary with respect to secondary, multiplied by the secondary rate. Then you have the connected rate of change. Done. Okay, so number 5 again. Remember that if it only mentioned rate of change, it means that, or rate, it means that it is rate of change with respect to time. Okay, so for example here, the volume of spherical bubble is increasing at the rate of 5 centimeter cube per second. So rate means, if it doesn't say anything else after that, is with respect to time. Okay, so number 6, another tip is that if you find it confusing to identify which is which, is it dv over dt, is it dv over dr, okay, so focus on the units. The units can tell you, can give you hints. For example, cm cube s to the power of minus 1 is centimeter cube per 1 second, one time, 1 unit of time, second here. So cm cube is a unit of volume, second is a unit for time, so this is rate of volume. Another example, cm s to the power of minus 1, which is centimeter per second. Centimeter is a unit for length, for example radius, it can be the length of height or whatever, and s again is time, so this is rate of radius. Alright, so the next step of success is, after you have constructed the rate of change formula, okay, identify the information that you have. So do I have dv over dt? Can I find dv over dr? What do I need to find? And then if you do that, then you can finally easily answer your question. So number 8 is just to remind you again that we can have a decreasing rate. Okay, so if you have a decreasing rate of change, it should have a negative sign. For example, the area of circle is decreasing at the rate. Rate means with respect to time. Right, so it means dA over dt is minus 7 centimeters squared per second. So take your time to read this step to success. Inshallah, I can help you. Alright, so let's briefly go through this example. So we have a volume of spherical bubble increasing at the rate of 5 centimeter cube per second. Find the rate which the radius is increasing, and the radius is 4 centimeter. Okay, now first let's try to identify the two variables which are involved in this question. So it is volume of the sphere and its radius. Okay, it's always going to be two variables. Next, you need to find the equation that relates the volume of sphere and its radius, which is this one. Third step, we need to identify which one is primary variable and secondary variable. And then you have to construct the connected rate of change. Okay, so follow the step to success. Alright, and then we need to identify which is which. So let's read the question again. So the volume of spherical bubble is increasing at the rate, so which means dv over dt. So dv over dt is 5 centimeter cube per second. So we have that. Right, the question, they ask you to find the rate at which the radius is increasing. So rate only, so which means dr over dt. So you need to find dr over dt when r equals to 4. Alright, so if you look at your constructed connected rate of change, so you have dv over dt, you need to find dr over dt. So you're missing dv over dr. So you need to find dv over dr. So what is dv over dr? Rate of change of v with respect to r. So you have to find an equation relating v with r, which we have already here. So you have v equals to 4 over 3 pi r cubed. Differentiate dv over dr, we have 4 pi r squared. Now remember, 4 over 3 pi is a constant, so you just set it aside and then just differentiate r cubed. In the end you get this. Alright, so now we have all the information, you substitute. Dv over dt is 5, dv over dr is 4 pi r squared, and we need to find dr over dt. Alright, so move this to the other side, becomes divide, you have this, and then we have r here, so substitute 4, you get this answer. Always write your units. Okay, so since this is radius, rate of radius with time, so it should be centimeter over second, so centimeter s minus 1. Alright, so this next question is a little bit tricky. The reason why is because they're going to mention more than 2 variables. So we have area here, and then length here, and then in the end they're going to talk about volume. So remember when I say we only need 2 variables, alright, so you cannot have 3. So I want you to read the question step by step, do it one by one. Okay, focus on question 1 first, and then you do the next one to avoid confusion. So let's try and do the first one. So the figure shows a rectangular metallic block, right, with the length of 4, cross section of a square. Alright, so the block is heated and the area, focusing on our area, increases at a constant rate, which is dA over dt. So they ask you to find dA over dx, not dA over dt. dA over dt is 0.03. So how am I going to do that? So dA over dx means the relationship differentiation of a with respect to the length x. So you need to find the formula which relates the area with length. So square, for square we have area equals to side by side, or length times by length. So what is my length of the cross section area? X each side. So a equals to x squared. Alright, so differentiate a with respect to x, you have dA over dx, which is 2x. Alright, so the second question is to find the rate of increase of x. What is rate of increase of x? This is dx over dt. So when x equals to 5. So the area of cross section area increases at constant rate of 0.003 centimeter square per second. This is dA over dt. Okay? So we construct your connected rate of change. dA over dt equals to dA over dx times by dx over dt. Substitute whatever you have, then you can find your dx over dt. Done. Okay, so the last part, find the rate of increase of the volume. Now we're talking about volume now. So we are dealing with a new story of volume with its length. We don't care about area anymore. So let's find the equation that relates volume with its length. So volume equals to length times by height times by width. So substitute, so you get volume equals to 4x cubed. Now differentiate dv over dx, you have 12x squared. We're going to use this later. So here our primary variable is v, secondary variable is x. Alright, so rate of change of volume when x equals to 5 means dv over dt. You need to find dv over dt. So construct your connected rate of change again, then substitute whatever you have. Now dx over dt, you already find it from the second part, so you just substitute here, dx over 0.03. Right, and do the maths part, then you get your answer. Okay, so that's connected rate of change. So I want you to try the next few questions. If you have question, you can just try and ask me. Okay, so follow the step to success because it can help you a lot. Alright,